Greetings, programmers. Today I want to talk to you a little bit about collision detection and how we handle collision detections when they relate to objects. So to get started with this project, I have some code here that I'd like to go over, and we're going to add to this code. We're going to create two things. We're going to create a player, and we're going to create an object on the screen that we're going to collide with. So let's start with the basic things that we have here. We've initialized our PYGAME. And then set the size of the window to 640 by 480. So let's make that a little bit bigger. I used some pretty big graphics this time. So I'm going to make that 800 by 600. And then we're setting the size of the screen. And I have a color set for black and green. I do recommend that you do set some colors early on so that you have them to work with as you develop your game. I'm creating a player on the screen. It's just a basic rectangle. It starts at 0, 0 and has a width and height of 64. Setting the frame rate, and then we have our game loop. Inside the game loop we have the event that is checking for pygame.quit, and then we have the key listening that will help us move the character around the screen. And then I'm filling the screen with green, and then flipping the display, and then ticking the clock. Okay, so that's going to be our basic setup. As you can see, I don't have anything drawing on the screen yet, and that's where we're going to start. So the very first thing I want to do is I created two graphics just before I started this project. First thing I'd like to do is go ahead and load my player graphic. So I'm going to call it player image. Okay. And remember to convert the alpha on that. Okay. Now another thing I want to do, instead of using the rectangle that I created here, when you load an image, it actually generates a rectangle that is a bounding box of that image. And I'd actually like to use that rectangle because it's going to be more accurate about where that object is. So I'm going to change this rectangle that the player is represented by to being the player image rectangle. So I'm going to get rectangle on that player image. And again, I found that by looking in the PYGAME documentation. And then I'm going to relocate the player on the screen. So I'm going to recenter it to 100, 100. Alright, so let's go down and actually draw that player on the screen. So I'm going to blit it, and that's going to be the player image, and I want to use the player's location. Okay, let me just check, making sure everything is okay. Everything looks fantastic, so let's try that. Uh-oh. Alright, let's see what I did wrong here. This is on line 12. Oh, can't call it. I need to set it. So I player.center equals 100 by 100. Alright, there we go. So there's my player, a giant penguin. Groovy. Okay, now that I have my penguin on the screen, what I'd like to do is to add the object that's going to be my obstacle. So for my obstacle, I'm going to put a crate on the screen. So I'm going to call it crate image. Okay, and this was a crate PNG file. Okay. And again, I want to relocate this on the screen. So let's put this dead in the middle. So it's going to be 400 by 300. Okay, and then I also want to draw this to the screen. So I'm going to go down to where we do our drawing and blit the crate to the screen. And there we go, I have a crate right there in the middle of the screen. And you see right now my penguin can walk through the crate. But we want to stop that. We want it to block it. Okay, so in order to do this collision detection, we're going to use the hitbox collision. And the way we're going to use it, I actually want to write a function to do this. And at the end of this, you'll have a pretty clear understanding of why we want to use a function. So you can actually define the function pretty much anywhere in your PyGame file you want. Do it before the game loop so that you can actually use it in the game loop. Let's see, where do I want to put it? Let's put it in between the import statement and the PyGame init. So I'm going to call this function collision. C-O-L-L-I-S-I-O-N. And what I want to do is we're going to pass in the player and the crate. But because I want this to be generic, I want it to be able to pass in any two objects. So I'm going to give these objects names. I'm going to call the first one source and the second one target. Okay, and so what I want to do in here, the very first thing I want to check to see if the things are actually already colliding. So we do that by using the hitbox collision that we looked at in the hitbox collision video. And so we say if not source dot collide rectangle the target, all we're going to do is return. So that means if the two things aren't colliding, we're done with this function and we're just going to get out of it. So that means everything else that happens in this function is a result of there being a collision. So the first thing I want to do is grab that overlap, right? And we get that by clipping the rectangle out of the target, and you'll remember that from the hitbox video. Now, this is where this is different from that project, because now we're actually going to do something with it. And what we want to do is we want to determine where the collision occurs. Because if we know where the collision occurs, then we can force action on the objects. So the first thing I want to know is the collision a vertical collision? In other words, is it coming from the top or bottom, or is it a horizontal collision? Is it coming from the left or right? And we can determine that because that overlap box that we have, actually let me show you real quick and you'll see what I'm talking about. Okay, so in this overlap, if I'm coming in from the top, you'll notice that that red box, it's wider than it is tall. Same thing if I come from the bottom, it's wider than it is tall. But if I come in from the side, it's taller than it is wide. So we can use that as a metric to say which way is that collision coming from. So in our collision detection function here, we're going to ask that question. I'm going to say if the overlap width is greater than the overlap height, then that means I have a vertical collision. Okay, and I'm just going to put pass in here for right now, and what the pass does, it says ignore this function for right now. And then I want to put an else statement in here, and I'm also going to put a pass in there. And so basically what we have here is if the first condition is true, then we need to check to see whether it was the top or the bottom it collided from. Otherwise, here we have a horizontal collision, and in that case we need to see did it come from the left or right. So let's do the vertical collision first. So we know that we have a vertical collision, and then I'm going to ask if the source.x is less than the target x, that means that the collision is happening. Let's see, the source.x would be less than, so that means that the collision is happening on the left side of the target. So this is a left side collision. Okay, and on a left side collision, what we want to do is the source should be pushed away from the target the width of that overlap. So the source dot right is going to equal the target dot left. And that's probably the easiest way to do this. So that's going to move that target where it should be. Otherwise, we need to move it to the right. So we're going to say the left side is equal to the target's right. So we can save this and look at it. And again, this pass here on the else is going to ignore that else statement, so I don't have to worry about blocking in that code yet. Alright, so I come over here, and when I come to the block, you should see, oops, it's going right through it. It's not getting pushed. Why are you not getting pushed? Oh, because we're not calling the collision yet. So let's come down into our game loop, and right here where we have the key, after we move the character, we want to check that collision. So we're going to say collision between the player and the crate. Alright, so now when we run it, helps you spell collide rectangle correctly. A little bit of a fix there. Fixie fix. Alrighty. So now when I come up to the crate, it's still... Oh, yep, top collision is working. Except not really. Oh, because I did it to the left and right. That's not correct. That's a vertical collision. So these should be Y. So actually, I can move these... since those deal with a horizontal collection down here. So, on the X, that's going to be a vertical collision. So, and then we'll put the pass in the first one to get past that error. There we go. So yeah, so now the horizontal collision works. Yep, I can't pass through it. But I can if I try to go through the top, but it's going to do that weird bounce thing. Alright. So let's go ahead and do that side. So this one is just a simple if the source.y is less than the target's y. That means it's a top collision. Okay, so we'll go ahead and fix that. So source.bottom equals target.top, and that'll automatically fix that. And then it's the other way around. Okay, so now we should have a solid collision on the top of the box too. Yep, and the bottom. Alright. Yep. Okay, so I want to show you just a little thing about why you want that this as a function, because I'm going to show you something else cool. Not only do we get object collision detection, so there's an obstacle there, but try moving these around. Put the crate first in the collision check and the player second, and you're going to see a really cool thing happen. So when I come over to this crate, when I collide with it, I actually push it. So the order that you do it in can give you this extra functionality, and that's a pretty cool feature of that collision detection. So I want you to play around with this, see what you can do with it, make some awesome games. Have fun.